Welcome to our discussion on bottom-up integration testing. Software development is a complex process, often likened to constructing a large building. Just as a building requires the careful assembly of individual bricks, beams, and walls, software is built from numerous smaller modules. Integration testing focuses on how these individual pieces work together, ensuring that the combined system functions as intended. Bottom-up integration testing is a specific approach to this process, starting with the smallest, most fundamental units of code, and progressively integrating and testing larger components until the entire system is operational. Imagine you are building a car. You wouldn't assemble the entire vehicle and then hope it starts. Instead, you would first test individual components like the engine, transmission, and brakes in isolation. Once you are confident in their individual functionality, you would then integrate and test larger subsystems, like the powertrain or braking system. Finally, with all subsystems working harmoniously, you would test the complete vehicle. This is the essence of bottom-up integration testing, applied to the realm of software. This approach offers several key advantages. By testing from the bottom up, we can isolate and identify defects early in the development cycle, when they are typically less costly to fix. This methodology also lends itself well to parallel development, as different teams can work on and test individual modules concurrently, speeding up the overall development process. Moreover, bottom-up testing provides a clear and structured approach to integration, reducing the risk of overlooking potential points of failure. In the following sections, we will delve deeper into the methodology of bottom-up integration testing, exploring its advantages and disadvantages, and examining its practical applications in modern software development. We will also discuss tools and techniques that can be employed to streamline the process and ensure its effectiveness. By the end of this essay, you will have a comprehensive understanding of bottom-up integration testing and its role in delivering robust and reliable software. The beauty of bottom-up integration testing lies in its systematic and incremental approach. We begin at the lowest level of our software with the smallest testable units, often referred to as units or modules. These units represent the most basic building blocks of our application, performing specific functions in isolation. Thorough unit testing is crucial at this stage to ensure that each individual component functions correctly before we proceed with integration. Once we have confidence in our individual units, we begin the integration process. We combine related units into small, manageable groups and test their interactions. These groups, often called subsystems or components, represent a higher level of functionality within our application. For instance, in a web application, a subsystem could be the user authentication module, responsible for handling user logins and managing session data. We test the interactions within this subsystem, ensuring that data flows correctly between its constituent units. As we move upward, we continue to integrate and test increasingly larger components, gradually building our application from the ground up. At each level, we verify that the integrated components interact correctly with each other and with any external dependencies. This process continues until we reach the highest level of our application, where we test the entire system as a whole. This final stage of integration testing ensures that all components work together seamlessly to deliver the desired functionality. To illustrate this process, let's consider a simple e-commerce application. At the lowest level, we might have units responsible for handling individual tasks like adding items to a shopping cart, calculating discounts, or processing payments. These units would be tested in isolation. Next, we might integrate the shopping cart and payment processing units to form a checkout subsystem. We would then test this subsystem to ensure that users can successfully add items to their cart and complete the checkout process. Finally, we would integrate the checkout subsystem with other parts of the application, such as the product catalog and user account management, to test the entire e-commerce system. Bottom-up integration testing offers several compelling advantages that make it a popular choice for many software development projects. One of its most significant benefits is the early detection of defects. By starting with the smallest units and progressively integrating them, we can identify and address issues at their source before they propagate to higher levels of the application. This early detection not only reduces the cost of fixing bugs, but also helps to prevent architectural flaws from becoming deeply embedded in the system. Another key advantage is the support for parallel development. Since bottom-up testing focuses on integrating and testing individual units and subsystems, different teams can work on and test these components concurrently. This parallel development can significantly accelerate the overall development process, especially for large and complex projects. Teams can work independently on different parts of the application, integrating and testing their work incrementally without being blocked by other teams. The structured and incremental nature of bottom-up testing also contributes to its effectiveness. By breaking down the integration process into manageable stages, we can systematically verify the functionality of each component and its interactions with other parts of the system. This methodical approach reduces the risk of overlooking potential points of failure and provides a clear roadmap for the integration process. It also facilitates easier debugging, as we can isolate issues to specific components or interactions based on the stage of integration at which they occur. Furthermore, bottom-up testing aligns well with the principles of modular software design. By focusing on integrating and testing individual units and subsystems, we encourage the development of loosely coupled and highly cohesive modules. This modularity enhances the maintainability and extensibility of the software, as changes to one module are less likely to impact others. It also simplifies the process of adding new features or modifying existing ones, as we can focus on specific modules without affecting the stability of the entire system. While bottom-up integration testing offers numerous advantages, it's essential to acknowledge its limitations. One notable drawback is the need for stubs and drivers. Since we are integrating from the bottom up, higher-level modules might depend on lower-level modules that are not yet developed or integrated. To overcome this, we need to create stubs, which are simplified simulations of missing modules, to allow testing to proceed. Similarly, drivers are temporary code modules used to call and test lower-level modules in isolation. Developing and maintaining these stubs and drivers can add complexity and overhead to the testing process. Another potential disadvantage is the risk of overlooking system-level issues. While bottom-up testing excels at identifying and addressing low-level defects, it might not be as effective at uncovering problems that emerge only when the entire system is integrated and operating as a whole. These issues could involve complex interactions between multiple components or subtle timing dependencies that are difficult to replicate at lower levels of integration. Therefore, it's crucial to complement bottom-up testing with other testing techniques, such as system testing and acceptance testing, to ensure comprehensive coverage. The reliance on stubs and drivers, while necessary, can also introduce its own set of challenges. Stubs, being simplified simulations, might not accurately represent the behavior of the actual modules they are replacing. This discrepancy could lead to false positives or mask potential integration problems that would only surface when the real modules are integrated. Drivers, on the other hand, can add complexity to the test environment and might not adequately exercise the full range of functionality of the modules they are testing. Moreover, the incremental nature of bottom-up testing can sometimes lead to a false sense of progress. As we successfully integrate and test individual units and subsystems, it's easy to assume that the entire system is progressing smoothly. However, this perception can be misleading, as critical integration issues might only become apparent at later stages when larger components are combined. Therefore, it's crucial to maintain a holistic view of the system and not solely rely on the success of individual integration tests.